Welcome to GHPujar Info YouTube channel. Subscribe this channel and also hit the bell icon to get the notifications of all the upcoming videos.
In this experiment, we will give information regarding dielectric constant experiment. The aim of experiment is to determine the dielectric constant of a dielectric material by RC charging and discharging method. The apparatus required for these experiments are 5-volt DC power supply. So this is the DC power supply. RC charging and discharging setup. So this whole setup is called as the RC charging and discharging setup. So which consists of one digital clock, one DC voltmeter, and set of resistors, set of capacitors with charging and discharging setup. So these are the minimum apparatus required for this experiment. So to determine the value of dielectric constant, we are using this formula, that is epsilon r is equal to d t half into 10 raised to minus 6 divided by epsilon naught a into 0.693 into r, where d is the thickness of the dielectric material, a is the area of the dielectric material, t half is the time required for 50% charge or discharge in the experiment, epsilon naught is the permittivity of the free space, and R is the resistance of resistors in a resistor in the circuit. So next, come to the experimental setup. This is the circuit what we are using in this experiment. So this is the setup, and the same circuit what we have here, it is mentioned in the experimental setup. The same setup what we have mentioned in the manual, the same here also. So where the connection starts with the battery. So now connect the DC power supply to the circuit, that is the first point. This is the first point. Next, connect this resistor. So here we have resistor, but the set of resistors here, 3 different set of resistors are there. Out of 3 different resistors, connect, so I will consider this one as 100 kilo ohm, so here the second point is connect resistor one end to the lower end and other end to the upper end of this one. That is, it means that the 100 kilo ohm now it is applied to the circuit. And here we have, this is the capacitor. Again we have 3 different set of capacitors. In that I choose the C2 capacitor. For that, connect upper terminal of capacitor to the upper terminal and lower point to the lower terminal of C2. So this is the C2. This is the second point. So third point. And the last one is, this is the voltmeter what we have. Connect voltmeter positive to the positive terminal and negative to the negative terminal. Okay, I repeat the connection. The first point is connect power supply to the circuit. Second point, we have different set of resistors. Out of that, select 100 kilo ohm. 100 kilo ohm. Connect the lower terminal to the first terminal of resistor and the second terminal to the upper terminal. And the third point is connect capacitor terminal, that is by selecting the setup we have different set of capacitors. In that, choose C2, the upper terminal connect to upper terminal and lower terminal connect to lower terminal. So next, the last point is connect this voltmeter positive to positive and negative to negative. Then switch on the circuit. Make sure both digital stop clock and digital voltmeter should read 00. If not, just take one wire and short the capacitor. So now this is the initial setup what we have to do. So make sure that both readings should be 00. So next, in the formula we need That is, to estimate the dielectric constant, we need t value, t half, epsilon naught, a and r bar. So anyway, in this experiment, from the observation part, we can find these values. That is, length of the dielectric metal is given, breadth of dielectric metal is given, and convert, this is in terms of millimeter is there, convert in terms of meters, that is 114 into 10 raised to minus 3, 5 into 10 raised to minus 3. Next, thickness of the dielectric is given, that is d is equal to 0.075. In terms of meters, we can write it in terms of that is 10 raised to minus 3. Then with the help of length and breadth, we can find the area. That's what we need. In this one, area we need. So therefore, calculate area using length and breadth. So multiply length and breadth, calculate the value of area. And epsilon value is anyway constant. So that is also required to estimate the dielectric constant. Next, the resistance in the circuit, that is, we applied 100 kilo ohm. Note here, that is 100 kilo ohm. That is also required. So now we know the value of D, we know the value of epsilon naught, we know the value of A, R, and only we need to find this value, that is T half. So this T half value can be obtained using the experiment. That is by charging and discharging method. That is how to find the T5. Let's start this one. So where we can note down the charging voltage across the capacitor as a function of temperature. So this is the time, this is the charging mode, and this is the discharging mode. How to find this voltage across the capacitor while charging and discharging? Let's come to the experimental part. So this is the experimental connection where what we already done. Now how to do that? Make sure that in this setup the knob has to be towards this C. C indicates charging mode. Make sure that it is charging mode. And here we have one more setup. This is halt and start. Halt means for stopping and start means for it will start. And we have one more setup, that is set and reset for the time, digital stop clock, to set and reset. So now by making sure all this kind of setups, start the experiment. As once if you start this one, so once if you press this knob, the time will start to run and corresponding voltage also. So where note on the values of voltage across capacitor for every regular interval of 5 seconds. For example, 5 here, 0, 0, next 5 seconds, 5, 10 seconds, 15 seconds, 20 seconds, 25, 30. Likewise, note on the values of voltage across capacitor as a function of time. This is for charging mode. Once the charging mode is completed, say for example you can note on the values up to say for example 110 seconds. Once if it is done, this one, and note down the last reading here, and here without disturbing this one, press this reset button and discharging mode and leave it, and started to note on the again discharging mode here. So note on the last reading as first reading and note on the value of now decreasing readings. So now as a function of the capacitor started to discharge. Note on these values till 110 seconds. So once if you note down these values, that is both charging as well as discharging. Next, plot the graph of voltage versus time. That is taking the voltage values along the y-axis and time along the x-axis. This is the time along the x-axis. This is the voltage for charging and discharging mode. So now plot the graph. So 0 second, note the value of voltage. 5 seconds, note the value. 10 seconds, 15 seconds. Likewise, plot the graph of voltage versus time for charging mode, and similarly for discharging mode. So once if you get these two plots, make sure that where the charging plot and discharging plot, where they are intersecting, note down that point, and for that point take the vertical section along the x-axis. So where this vertical section meets the x-axis, so that corresponding time is considered as t-half value. So that is the time for exactly 50% charge or discharge of capacitor. From this graph, note that value as t-half some seconds. So from this plot, now using that t-half value, calculate the value of dielectric constant. We know the value d. We know the value of t-half now using the graph. Epsilon naught is constant, A is calculated, R is the resistance value. Substituting all the values, we can find the dielectric constant of the material and finally write in the results.